Thanks, Jason. Hi, my name is Kimon Tsinteris, and I'm here to talk about animations, in particular going beyond static animations. So what are static animations? Well, ever since the original iPhone, iOS has shipped with 4 basic animations out of the box. You're probably familiar with them. Linear, ease in, ease out, ease in, ease out. Behind these animations is core animation. That's actually the framework that's driving these. And core animation is a very efficient way of animating layers. Many credit core animation, in fact, with one of the distinguishing factors between iPhone and the competition. But what if you need to go beyond those static animations? What if you wanted to take into account velocity? That's very common when you're trying to animate something using the flick of a user's gesture. What if you had custom properties that you want to animate, or custom objects, or create other custom animations? Core animation actually gets really tricky here. You can kind of fudge it using a keyframe animation, but that takes a lot of trying and failing. I still remember trying to do my first spring keyframe animation, and it's actually really, really hard to get right. And even if you do it, it never feels quite right. Lastly, what if what you're animating isn't a CA layer? You're out of luck. OK, so what options do you have? Just recently, in iOS 7, Apple introduced UI Dynamics. And UI Dynamics is a really interesting framework. It's very full-featured, and it basically lets you describe your objects in terms of behaviors, physical properties. The thing is, it has a finite set of properties that you can animate, and it requires a paradigm shift. It's actually kind of complicated. You basically have to throw out all your static code and write new dynamic code. So what if for some reason you can't use UI Dynamics? The last option is Homegrown. What does that look like? Basically, it means you have to create a CA display link, manage that, create your own render time function, and then start keeping track of lots and lots of state. The start time of your animation, the current time, to-value progress. Then you have to do some math. You basically have to interpolate. Maybe you have to do some physics. It pretty quickly gets very messy. So in Paper, we have a lot of animations. If you see here, and you've probably all used Paper, there's sliding, there's bouncing, there's unfolding. We're an animation-heavy app. These are actually what bring the application to life. So what did we do? We created Pop. Pop is the animation engine behind all of Paper's animations. It's driving those animations and transitions that you and all our users have come to love. Now, Pop has actually been around for a while. It was first built at Push Pop Press, but we really honed it and refined it during the development of Paper. So in creating an animation framework, what were our goals? We basically wanted to make the animation that we use most really, really convenient. We also wanted to make it an extensible framework. If for some reason there was an animation that wasn't handled out of the box, we should be able to plug into the framework instead of scrapping everything and starting anew. Lastly, we really needed to make it developer-friendly. Paper is chock full of animations, and they're interruptible. Users can interact with those objects. We really wanted to support that kind of interface. So, diving in a little, we basically started with the 4 animations that we've all grown to love, the static animations. And we added 3 new types out of the box: Spring, Decay, and Custom. Now, Spring and Decay are the ones that you see all throughout Paper. And most important thing to know about Spring and Decay is that they take velocity as an input parameter. And that's very, very important to have your animations feel natural when they're coming off a user's flick. Custom, the other first primitive out-of-box animation type that we've added, is basically recognizing that an animation framework can't do it all. You can basically tap in to Pop and write your own custom animation. So now, here's Core Animation API. How did we go about doing this? The Core Animation API is actually quite nice. It's very powerful. It lets you add animations, stop animations. But it also, most importantly, lets you query your layers for the currently active running animations. So this is the Pop API. It should actually look very, very similar to anybody that's done core animation. It keeps the same flexibility of being able to query for running animations. One of the only differences is that the basic object is a pop animation object. The other key difference is that it's implemented as a category on NS object. And this is really important. This basically recognizes that you can animate anything. So now let's take a look at what it takes to go from a static animation using core animation to something a little bit more dynamic using pop. Here is basically the 4 lines of code, core animation code, to animate layers bounds. Here it is in pop. It should look very, very similar. It's effectively the same 4 lines of code. Now, I mentioned extensible. What if you want to animate your own custom property? Pop, you can do that too. Animating is basically just change over time, if you think about it. So here is a sample little property that shows how you'd animate the volume of something, your radio. Basically, all you have to do is define a read block, a write block, and then a threshold. And threshold is, just think of it as the smallest significant amount of change. This hint to the system is actually very valuable when you're working with dynamic quiescing animations. Now, I'd like to show you a demo. Could we switch to the demo machine? Great. OK. As you'll see, first and foremost, we've ported Pop to OS X as well. Here's a spring animation. It looks pretty good, even just out of the box. But we can tweak it. We spent a good amount of time coming up with two parameters, speed and bounciness. And they're just that. You can increase the speed. Your animation speed increases. You can decrease the speed. It decreases. Now let's crank up the bounciness and see what that looks like. Exactly what you'd expect, right? Notice I'm just toggling animation. The animation isn't quiescing. I'm just taking an animation and just re-vectoring it. That's actually very key to building fluid, responsive applications and interfaces. What does that look like in Pop? So here you basically have a property that returns a spring animation, creating one if needed. We're animating the bounds. We moved on completion equal to no. So some of you that know core animation, this should look very, very familiar. And here's the toggle image IB action. It's basically just toggling the to value of the spring animation. And basically what that is doing, there's no additional state being tracked, whether the image is expanded or collapsed. We're basically just updating the to value of an animation and letting the system converge. We're letting the animation object converge to that destination value. Great. Can we go back to the slides? Cool. Thank you. OK, so Pop is actually a pretty big framework. And it has more features than we can talk about today in this presentation. As I mentioned, it has a familiar API. It's an animation engine that's decoupled from the type of object that you're trying to animate. It's extensible. It also has tracing. So this is actually really huge as far as being able to debug what your animations are doing, basically recording all the values, property changes to the animation, as well as updates to the objects that you're animating. It's used extensively in unit tests. And as you saw, we have it in paper and on OS X. Now, we'd like to announce that we're going to be open sourcing it. So as you've noticed, thanks. as you noticed, we've been on a bit of a roll, and we've started open sourcing a number of the technology underlying paper. So Pop is joining kind of a family of utilities and frameworks that we've released recently. And I just wanted to kind of briefly walk through them. KVO controller came first. KVO controller, check it out. It's basically a way of kind of doing thread-safe, modern key value observing. It adds blocks and all sorts of niceties. A nice, simple utility class that we definitely take advantage of within paper. We also open sourced Shimmer a few weeks ago. So if you don't know Shimmer, Shimmer is basically used extensively in paper. It's that loading indicator effect. And up on GitHub, it basically lets you add that same effect and tweaking it to your heart's delight to any view or layer. Lastly, just a few weeks ago, we open sourced Tweaks. And Tweaks are great, honestly. It's basically a framework that allows you to tweak values. And it turns out works really, really well with Pop in tandem. When you have these types of animations, you don't really want to have to recompile and relaunch the app just so that you can change a value just to see what it feels like. And it turns out Tweaks works really well with Pop and physics-based animations. Now, in the coming weeks, you'll be able to find Pop at this URL on GitHub. If you would like pre-release access, just see me after the presentations, and we might be able to arrange something, but it should be very shortly. Also of note, coming soon, is integration with Origami. I don't know if everybody knows, but Origami is basically a design prototyping tool that we use extensively within Facebook. And animations like the ones that you saw are also supported. The same values that your designer is going to basically hand you for bounciness and speed are going to be directly applicable to when you're using Pop. Thanks. Up next. Up next is Brian. He's going to talk about advanced gestural interactions. Thank you.